This is Professor Pelton. This is part 5 of Chapter 3, Section 7. Now we're going to look specifically at the graphs of functions and their inverse. So essentially, the y equals x line of symmetry is what you use to visually look at that they are, in fact, inverses of each other. Because essentially, algebraically, you switched x and y when you solve them algebraically if they actually existed. So therefore, they should be symmetric on that same line, essentially. So essentially, it's a line y equals 1 over 1x plus 0. So the y-intercept is 0, right? And the slope is 1 over 1, because all you're doing is switching the x and y values. Okay, so no matter what the graph looks like, it should be symmetrical. Okay, all right, so let's do a few of these to take a look at what they look at visually. All right, so this is the original function, f of x. Let's see if the inverse function actually exists. So first off, is it 1-to-1, and does it pass the horizontal line test? Yes, passes both of those. All right, so if I switch the variables, I'm going to get -2, -3. And if I switch the variables, I'm going to get 0, -1. All right, 0, -1. And if I switch the variables, I'm going to get 2, 4. Okay, so if I connect the dots now, I get that there. Okay, and if you look visually at the y equals x line, right, that's y equals x, they are foldable on that line of symmetry, right? So the inverse exists, right? And the inverse passes the vertical line test. My line's a little curvy, it's supposed to be straight, but best I can do with that marker there. Okay, so if I look at the next one, right, is it 1-to-1, and does it pass the horizontal line test? No. If I draw a horizontal line, it's going to fail, right? So it is not 1-to-1, right? And does not pass the horizontal line test. Because if I tried to actually graph it, it would not be an actual function for the inverse. If I take any one of these coordinates, so take this coordinate here, so that coordinate is 0, -1. So if I flip that, I would get -1, 0, right? So take two more coordinates. We'll take these ones up here that I took, which were 2 and 3, and -2 and 3. Okay, let's change colors. So if I flip that, it's going to be 1, 2, 3, and +2, and 1, 2, 3, and -2, right? If I flip the values, so I would get a graph that looks like this, and that graph clearly doesn't pass the vertical line test. So we doubly prove what we already knew, that the inverse function does not exist. So the inverse function does not exist. In order to make it exist, we have to do some kind of domain restriction, which we'll do in the next part. All right, pause the video. Try the student problems for yourself. Okay, so we'll try the square root of x plus 1. Okay, so I'll make a nice little table of values. We don't need very many, to be honest. So the easiest values to plug in are 0. What else can we plug in? Well, actually, we can do better than that, actually, because of the +1 that's in there. We just can't do square roots of negatives because that would not be real. So I'll plug in -1 because that'll give me 0. I'll plug in 0 because that gives me 1. I'll plug in, let's see, 3 will give me 4. And if I plug in 8, that'll give me 9, right? All right, so if I plug in -1, I get the square root of -1 plus 1, which is 0. If I plug in 0, I get the square root of 1, which is 1. If I plug in 3, that's 4. Square root of 4 is 2. Plug in 8, that's really 9. So square root of 9 is 3. So at -1, I'm at 0. At 0, I'm at 1. At 3, 1, 2, 3, I'm at 2. and then I'm off the graph for the rest of them, but that's fine. We just get that little graph right there. So two things. Does it pass the horizontal line test? Yes. Is it one-to-one? Yes. Does the inverse exist? Yes. So the f function inverse exists, right? So if I want the table of values, all I have to do is switch them basically, right? So if I switch them, I'm going to get 0, 1, right? Or 0, -1. So when I go to 0 and go to -1, so 0, -1. Then my next one, 0, 1 becomes 1, 0. And then 3, 2 becomes 2, 1, 2, 3. And then 8, 3 becomes 3, 8, which is off the graph. So basically I'm just going like this, right? So that passes the symmetry test also visually. Okay, so let's try x squared plus 1. So we'll just do a table of values here, x and y. We'll just plug in -2, -1, 0, 1, and 2. Okay, so it's -2 squared plus 1, yeah, using this function, right? So that's 4 plus 1 is 5. If I plug in -1, that's 1 plus 1 is 2. 0 gives me 1. Then I get 2, then I get 5, right? So at -2, I'm at 5. At -1, I'm at 2. 0, I'm at 1. 1, I'm at 2. And 2, I'm at 5. Okay, so the question is this one-to-one, and does it pass the horizontal line test? No, because 5 clearly maps to 2 and -2, so it's not one-to-one. It also does not pass the horizontal line test. So basically, the inverse of the function, is it f? Yes, does not exist without a domain restriction. Okay, that is the end of this part.